All right, so we're on 8-2, the Pythagorean Theorem and its converse. So like we just talked about, most of this should be pretty easy for you. You should already know the Pythagorean Theorem, a squared plus b squared equals c squared, where c is your hypotenuse or your longest side of a right triangle. You guys already knew that. You've known that for forever. So this maybe is a new concept to you, Pythagorean triple. It's three non-zero numbers that satisfy the Pythagorean theorem. For example, 3, 4, 5. That's a common right triangle that we see. So whenever I see a triangle that looks like this, maybe one leg's 3 and the hypotenuse is 5, I know the other leg is 4 without doing any math. It's a 3, 4, 5 triangle. So if you know those, great. You don't have to. You can still do the Pythagorean theorem every time. But these are so common and they happen often enough that it's kind of nice to know. Does that make sense? You don't have to. Okay? All right, this is new to you. Theorem 8.6 and 8.7. If a squared plus b squared is greater than c squared, then the triangle is acute. If a squared plus b squared is less than c squared, then the triangle is obtuse. So kind of backwards of what I would have thought. Okay? All right, so with pretty much this whole chapter, they probably want you to leave it in radical form and not decimals. So if they have like the square root of 12, they'll want the 4 and the 3 and the 2 root 3 is what I'm saying. So on this one, you would do a squared plus b squared equals c squared. So if you really want to go way back, you can actually write it down. That's fine. 12 squared plus 16 squared equals x squared. But obviously, you can just plug that whole thing into your calculator. So what do you get when you do all of it and square root both sides? Which is 20. You just get x is 20. Did anyone not get that and need me to help you? Okay. I told you to go ahead and skip this one for just a moment. It's not like it's no harder than the other ones. It's just that it's fractions and that freaks people out. So we'll come back to that in a second. All right, 17. This one, if you wanted to show work, would be x squared plus 24 squared equals hypotenuse squared. But again, you can plug that whole thing into your calculator. You don't have to write those down anymore. But if it helps you, you can too. It's totally up to you. What do you guys get for x? You should get 70. Did anyone not get 70 and need me to work it out for you? Are you sure? So when it's the normal straightforward questions, you guys are totally fine with the Pythagorean theorem, right? So let's go back to this one. For ones like this, I would probably write it down. I mean, again, you can use your calculator, it's fine. But when fractions freak you out, it probably wouldn't hurt to write it down. So 4 over 9 squared plus x squared is 8 over 9 squared. Again, you can use your calculator the whole time. I'm going to do it by hand, but you guys want to, if you want to try your calculator, go ahead. So if you do your calculator, you're going to get, I'll just go to the x squared part. You're going to get 16 over 27. So everybody try your calculator and see if you get there. And if you don't, then I'll just do it by hand and I'll show you what you did wrong on your calculator. And we'll square root it and stuff like that together in just a second. Anyone not get 16 over 27? Okay. If you did do it by hand, that would be 16 over 81. You square the numerator and the denominator, and that would be 64 over 81. So obviously, you're going to take the 64 over 81 and subtract the 16 over 81, and you end up with, if you reduce it, the 16 over 27. So everybody's at least here now, okay? When you square root both sides, again, they said simplified radical form, so your calculator really isn't going to help you here. So I'm going to go ahead and just write it as 16 over 27 under a square root sign, because both of those are not perfect squares, so your calculator isn't helpful. It would give you a weird decimal, okay? So what we're going to have to do is remember how to simplify square roots. I'm going to go ahead and pull them apart like this. 16 is a perfect square. Is everybody comfortable with what I just did? Okay. Why is that not allowed to stay like that? Yeah. You can't have a root in the bottom. You can't have a root in the denominator. So what I'm going to have to do is rationalize the denominator. If you're in Algebra 2 right now, this should be somewhat easy for you. If you're not, it's going to be a while to remember, right? So the way we get rid of it, do you guys want to just multiply by root 27, or do you guys want to simplify the root 27 first? It doesn't matter either way. Just multiply now? Okay. If you guys want me to go back and simplify instead first, just let me know. But either way, you end up with the same answer. Okay. So what you do to the bottom, you have to do to the top. So obviously that's 4 root 27. There's not much I can do there yet. When you take a square root times itself, it just gives you itself, right? So if you wanted to use your calculator, you can. You could take 27 times 27, but when you square root it, you get 27. Do you understand what I'm saying? That's a property, okay? So the root 27 has a perfect square inside of it. What perfect square goes into 27 evenly? 9 and 3. What is the square root of 9? We've got the 4 times the 3. The square root of 3 is still there. So that's 12. Square root of 3 over 27. And what's 12 over 27 reduced to? 4 over, what did you say? 4 over what? 9, yeah. So 4 root 3 over 9. That's just one way to do it. I'm happy to show you the other option too if you want. I know that simplifying square roots when they're in the denominator is kind of tricky for people. So sometimes you just need to see it again, or you need to see it a different way. So what we did was totally fine. I'm going to go back to here, and I'm going to go ahead and simplify the square root of 27 first, and then rationalize the denominator. Either way, okay? So if I have 4 over square root of 27, I'm going to change that to the 9 and the 3, okay? So 4 over 3 root 3. So now what's the only thing that needs to go away? That root 3, right? It's the same concept as before. You're going to multiply by the square root of 3. So I get 4 square root of 3 over. This 3 is still here. It didn't go anywhere. These become square root of 9, which is 3. Whenever you take a square root times itself, the square roots cancel out. So I'm left with 4 root 3 over 9. So if that was easier, do it that way. Same thing. Is that okay? Okay, backside. Oh, do 18. All right, 18, there's nothing fancy. So why don't you guys try 18 and see if you can get it. If you've been writing it down every single time, that's totally fine, but I'd like you to try to do it without writing it down just in the calculator. So obviously that would be 78 squared minus 72 squared, hit the equal sign and square root that. Yep, you should get 30. Anyone not get 30 and need help? So the directions said use Pythagorean triple. You can, that's fine, but it's not necessary. I don't care either way. So most of you, I think, just did Pythagorean theorem, and that's okay. Okay? So here's the sort of new part, I guess. Determine whether each set of numbers can be the sides of a triangle. So step 1, is it a triangle, yes or no? Okay. If it is a triangle, classify it as acute, obtuse, or right. So how do we see if something's a triangle or not? Yes. Small plus medium has to be bigger than large. Small plus medium has to be bigger than large. So on number 21, I'm going to see if 7 plus 15 is bigger than 21, question mark, right? What is 7 plus 15? Is 22 bigger than 21? So yes, it's a triangle. Okay, that's question 1. Question 2, is it acute, obtuse, or right? So if you go back to the beginning of our note here, we're going to say a squared plus b squared. If it's bigger than c squared, it's acute. If it's less than c squared, it's obtuse. What if it equals c squared? What kind of triangle would that be? The right triangle, fit the Pythagorean theorem, right? So even though this may not be a right triangle, c is still your biggest side here. So I'm going to say the 21 has to be the c squared, right? So I'm going to see if 7 squared plus 15 squared is, I don't know, 21 squared. I don't know if it's bigger, smaller, equal, I'm not sure. Okay, so 7 squared is 49. 15 squared, okay, if you don't know, you can plug it in. 225. 21 squared, 441. So take your 49 and your 225, add them up. 274 is less than 441. So is that acute or obtuse? Obtuse. You guys get that? Okay. Again, if they had been equal, it would have been the Pythagorean theorem itself, which means it had to have been a right triangle. Okay. On this one, we would see if 44 plus 46 is bigger than 91. What is 44 plus 46? Is 90 bigger than 91? No, so not a triangle. So it can't be any of the options anyway, because it didn't even make a triangle in the first place. Did I lose anybody? Super easy, right? Okay. I was just saying it is or it isn't a triangle. I wasn't saying like a similarity statement or anything. Is that what you mean? Yeah. So the first part of the question was, is it a triangle? If it is, what kind? Okay.